class session today. So the recording is on, and welcome again, everybody, to Data Structures CS46. Today, what we're going to be talking about is a little bit more background information on why Vim is a useful tool for this class. So Vim, again, is that text editor that we sort of started talking about last time and showed you how to use that Vim tutor command to start learning it. We'll also be talking a lot about the bash terminal in general and how do you use this terminal efficiently. So when you logged on to the Lambda server, whether you were using PuTTY or SSH or however you're connecting from Windows, Mac, doesn't matter. Once you do that connection, we say you're in the terminal environment on the Lambda server, and everybody's going to have the same terminal environment. So even though I'm on a Linux machine and most of you probably are not, you'll be able to do things exactly the same as I'm doing once you're logged in. So we'll talk about that today as well. And then the big picture thing, though, that we're actually going to talk about today is something called Git, which is one of these really kind of obscure, well, it's actually not obscure, but difficult, challenging, confusing command line programs, and how we use it to collaborate with other people on programming projects. All of the things that we're going to talk about today are sort of really foundational for the rest of this course. They're not really programming sort of things necessarily. We're not talking about Python or how do you code things, but it's a little bit one level above that of just how do you even get to the point where you can program things. So it's a really important course material today. If you do have any questions as we're going through things, again, always feel free to just turn your mic on and interrupt me and ask a question of oh, I did something and it didn't make sense, or ask me to repeat something. That's always okay to do. I probably end up talking a little bit faster on Zoom than I would on an in-person lecture, just because there's a little bit less feedback from you all. So definitely am open to being interrupted. But then there's also the chat window that I have two monitors open so I can see the chat as I'm sharing my screen. And if you have a question that's a little bit more broader, feel free to type it into the chat and I'll address it when we get to an appropriate time. Okay, before we start any of that stuff though, I want to just some real quick administrative announcement stuff. And the first thing is that we'll have a lab session tomorrow, Thursday morning. That lab session, you're not required to attend, just like you're not really required to attend these sort of live lectures. But as a reminder, you do get extensions on labs and homework assignment due dates if you attend the lab. And so related to that, now I'm going to share my screen. And you can see right now I have our course webpage pulled up right now on GitHub. And I'm going to click right here on the Issues tab. So this is where I'm going to be posting all of our announcements for the course. And just 24 minutes ago now, I posted a new announcement about the lab and homework assignment due dates for this week. And essentially, because the material that we're covering today is so important, and because it's the first week of class, and so things are all new, you're all getting adjusted to this new programming environment, I'm taking away any late penalties for this week. So nominally, things are due on Sunday, so you should try to accomplish the lab and the homework by Sunday. But if you run into trouble, for whatever reason, have questions that you can't fix, then it's better to submit it later and actually get those questions answered. Because it's very, very important that you fully understand all the concepts that we cover this week. The other important announcement is that, this is a GitHub repository that we're looking at right now. And there's this button up here in the top right. And you can see that right now, mine says unwatch, and that's because I'm currently watching this repository. And what I would like you all to do is to actually watch this repository. So for you, when you see this, it should say watch instead of unwatch, and you press that button. And what that will do is it means that every time I post a new announcement like this, you will get an email about that announcement. So after this week, I will not be sending out any emails directly to class. I will only be posting announcements onto GitHub. And so it's very important that you're watching this repository so you get notified when I make one of those announcements. Are there any questions about anything administrative-wise at this point? Okay, then we'll get started with the main class material today. So click back over here to week 0. And we're talking again about so Unix and the open source workflow, and in particular, working on a remote Unix server and all of everything that entails. So I'm going to switch right now my screen to have 2 terminals open. And let's see, I think maybe there's a bar at the top that you can't fully see my screen. So I'll try to not ever type anything on the top of the terminal, but if ever I am typing something and it's not displaying for you or font's too small, anything like that, just interrupt me and let me know. So right now I'm on these 2 terminals. I have 2 terminal windows open and both of them are connected to the Lambda server. So I've run that SSH command and I'm connected to the Lambda server. And currently this is just a test account that I just created, and there is nothing in my nothing on this account yet. So ls is one of the most important commands that you should know about for the terminal, and it is a what it stands for is list, and it lists all of the contents of a directory or of a folder. And right now there's nothing in here, so ls returns nothing. Actually, before I go on, I also wanted to mention that there were the cheat sheets on the, right here, these 4 cheat sheets that I recommended you print out before lecture today. I recommend that you have those in front of you as I'm going over all of these commands. And that would be the sort of the ideal spot for you to be taking notes about things. If there's something I say that you want to remember, that's on the appropriate cheat sheet would be the good spot to write it down. For these, yeah, so in this class, we have a final exam at the end of the semester. None of the stuff on the exam will be related in any way to these cheat sheets. These are, or these Unix concepts or these Git concepts, these concepts are really more for you to be able to complete the homeworks and projects. So don't feel like, yeah, if you look at these cheat sheets, there's like thousands of things. Don't feel like you have to memorize them. They can serve just as a reference for you so that you're able to accomplish the tasks that you need to get done. Okay, so I'm back at my terminal window, ls, there's nothing here. All of the commands in a Unix environment accept what are called command line arguments, and that is typing something after the name of the command. So here, ls, if I do ls-a, the -a stands for all, and it lists all of the files in a directory. And you notice there's all of these files that got listed start with a dot. These are called dot files or hidden files in Unix systems. If you use a Mac or a Windows, they have their own separate ways of calling a file a hidden file. But on any standard Unix system, if a file begins with a dot, that means it's hidden and not something that we normally want to display. These files here, so they, on your own system, when you log in for the first time, you'll have a bunch of these hidden files, these dot files in your we call it the home folder, the place where you first arrive when you connect. And these configure everything about your login system. So this vimrc file configures how your Vim program works. This terminal, another way for this terminal system is called bash. And this bash rc file controls how your terminal or how your bash shell actually works. In this class, you don't need to know all of those details about how to configure all of these things, but they will come up at various points, so just be aware that these things are here. So ls is a very important command. Another important command is pwd, stands for print working directory. And the working directory is the directory that you're currently inside of a Unix system. So this, when you first log in, your working directory will be /home/ whatever your username is. So my username is usertest, and so this is what my print working directory gives me. The next command is mkdir. Mkdir creates a new directory. So mk standing for make directory. And then I can give it a name, whatever I want it to be. I'll call it PROG for project. And now if I type ls, you can see that this folder now appears. It does not start with a dot, so that's why ls by itself makes it appear. And if I did ls-a, we can still see that this project folder exists, but also all of the other folders are getting printed out as well. So ls-a does not only print the hidden files, it prints all of the files, whether they're hidden or not hidden. And then the next command is the cd command, cd standing for change directory. And so I'm going to cd into prog. And you can see now over here, this is called my command prompt, my prompt. This has changed to indicate that I'm inside of the proj folder. The tilde, anytime you see a tilde on a Unix system, that is shorthand for your home directory. So up here, when I did pwd, we saw that my home folder is this right here. But this can be sort of cumbersome to write because it's just, I don't know, 15 characters or something, and programmers are lazy, and so often we'll just use the tilde to refer to our home folder. There's a great question in the chat right now about when I run the ls command, why are some things black and some things blue? And we'll get into a lot of details about that later in the course. There's a lot of other colors that can appear as well. But the short answer is that a black thing is just a file, and a blue thing is a folder that you can go inside of. Yeah, we'll see more examples of that here in a second. So now that I'm in this proj folder, if I run ls, we see that there's nothing there. And if I run ls-a, we see that there's these two things here, a dot and a dot dot, but there's none of these files up here, or none of these other folders. And that's because I'm inside of a different working directory right now. When you run the ls command, it only shows you the contents of the working directory that you're currently in. In order to go back to my home folder, I can do cd space and then paste the name of this folder right here, and that will take me back to my home folder. pwd prints my home folder, and now I do ls-a, see all that stuff again, cd proj ls-a, and it's not there anymore. This dot and dot dot, though, are really helpful for when you're navigating around using this cd command, because what dot dot refers to is whatever your parent folder is. So if I type pwd again, and this is the folder that I'm currently in, this is the, we'd call this the base name right here. Proj is the base name of this location, and /home/usertest is the parent folder of where I'm currently at. And so if I do cd dot dot, that will take me back up to my parent folder. If I'm back in proj and I make another folder, go inside that other folder. So now I'm in home usertest proj inside, and do cd dot dot, it takes me to project. Any questions so far about how to navigate where you're located at inside of the terminal here? Okay. If you do like have questions that are maybe end up being like bigger questions of something like, oh, you're trying to do something and it's not working the same way for you as it is for me, the lab sessions is where we're really gonna work on that thing, and we'll have a chance for you to all be able to share your screens, and I'll be able to look at exactly what's going on and why when you run a command, it's not doing the same thing as when I run a command, and help you debug that. Also, during the so the lab session on tomorrow is essentially going to ask you to redo a lot of the steps that we're going to do today with the git command. So it's okay if today, let's see, my screen just went blank. Can you all still see my terminal?
No, it's black for us too.
Okay. Well, that's weird. Well, what I'm going to do is I'm going to stop sharing my screen for a second and come back and see if that fixes things. If I can get it to stop sharing. Oops. Let's see, can you all see my screen now?
We can see your screen. I don't think you can see the terminal.
So you see Firefox open, but no terminal?
Yeah.
Okay. Oh, there we go. Can you all see the terminal again?
Yeah.
Okay. I apologize for that. I think, let's see. So I run a Linux on my own personal laptop, which is the same as what's running on this Lambda server. And I think Zoom is not, I'm not their target audience in getting all their bugs worked out. So occasionally some setbacks like that happen. Let's see. So the next thing that I want us to, or there's a great question in the chat about how do you delete a directory. And so if we do ls, we've created this folder right here. rmdir is the command for deleting a directory. rm standing for remove, dir for directory. And so rmdir and then the name of the directory will delete it. What we're going to go on to next is using this git command and interfacing with GitHub on the command line. So I'm going to switch over to Firefox here for a second, and seems to have deleted my other Firefox window. So on the right-hand window over here, I'm currently logged in with my normal account, and I want to log in with a different GitHub account now. So I'm going to go ahead and do that. There we go. And so this account that I'm logged in now is, the account name is called Example Student. And what I'm going to do is I'm going to go through the full process of what's called a pull request on GitHub. And in a pull request, the basic idea is to, if there's some repository that contains something on GitHub, but I don't have like control over that repository. I'm not the main, we'd say the owner or the maintainer of the repository, then I can't just change it. It's not like Wikipedia where everybody can change it and it's sort of total chaos. Instead, on GitHub, what we do is I suggest a change, which is what this pull request process is, and then the maintainer gets to decide whether to accept the change or reject the change. And the change that we're going to make is we're going to make this Unix, instead of being all uppercase, we're going to make it lowercase. There's a very subtle distinction in the Unix world about the difference between uppercase Unix and lowercase Unix. Uppercase Unix is a particular operating system that was invented in 1970 at Bell Labs and AT&T, and they had a software patent on the technology until the late 1980s. And once that patent ran out, then a lot of other systems, one of them being Linux, decided to sort of implement their own version of something that was similar to Unix. And those similar Unixes are just called lowercase Unix. So the Lambda server is one of these lowercase Unixes. And so this is an example of a typo in my GitHub repository, that this uppercase should be lowercase. If that's confusing about why it should be lowercase, that's totally okay. Just know that we're going through the process of how do you actually change something. And what we're changing is changing this from uppercase to lowercase. I'll also say that, so GitHub is extremely popular, very widely used in industry. And so here is an example of a Facebook GitHub repository for something called React. React is a framework that is used by Facebook to develop the Facebook webpage and a lot of other products that they own. And it's used by hundreds of other companies as well. Yeah, and so you can see it looks very similar setup to what our course repository is. And one of the main reasons why our course is set up this way is so that just by using the course, interacting with things, having our announcements posted as issues in GitHub, you get familiar with how, like, what is the industry standard for working on software projects. And so this process that I'm going through to fix a typo in the course repository is also the same process that you would go through if you were adding a new feature to the Facebook product, React. Everything is exactly the same. Okay, so while we're doing this, the cheat sheet to have like really in front of you is this one right here, the basic steps of a pull request. And this is sort of what we're going to be walking through. So first, we'll kind of be bouncing back between this sheet right here and the terminal and the main GitHub page. And so if ever there is a time where you say like, or you think I should go back to a different screen for a second, please speak up and let me know. Right now, I'm at what's called the Upstream repository. So on this cheat sheet right here, that's this cloud right here. And the Upstream repository is the original repository that I want to make a modification to, or a little bit better said, I want to suggest a modification to. And so in this class, when you're doing this, all of these repositories will be owned by me. And so it'll be something like github.com/mikeisbicky/ whatever the project name is. And that is our Upstream repository. And your first step is to do what's called forking the repository, which means adding it to your own account. This is something that happens in the GitHub webpage. And so up here in the top right corner, there's this button fork. And in order to fork the repository, you just press that button. It takes a second for the forking to happen. And what this is doing is it's just copying over all of the information onto your account. You'll see that like the web page looks very, very similar to what it used to look like, except now up here in the top left, it says example student, which is what I'm currently logged in as, / the name of the repository. And it says forked from, and here's the original repository. So I'm going to click on this button. That'll take us to the original repository. You can see that now it says Mike is Bicky up here, and it does not say forked from. So that's how I know it's the original repositories. It does not say forked from right here. And I'll go back now to the forked repository. And that's it for the first step. So that was taking the upstream and you fork it, and now it's it'll be github.com / whatever your username is / the name of the project. This original Upstream repository, everybody in the world has read access to it, but only I have write access to it. This one down here, everybody in the world has read access to it, but only you have write access to it. So I cannot modify what is in your repository right here, and you cannot modify what's in my repository up here. Again, this one up here is called the Upstream. The original repository is called the Upstream. The one that you just forked is called the Origin, or it'll sometimes be called the forked repository or the downstream repository. So we forked that, and now our next step is going to be doing this Git Clone. Git Clone is what's going to transfer the repository from the cloud, from the internet, onto the Lambda server. And so I'm going to come back to, there we go, to our project down here and do the Git Clone. So the command for this is just git clone and then the URL of the repository that you want to clone. So I'm going to come back to the web page, come up here, and this part is very important right here, that you want to clone the repository that is the origin repository, the forked repository. So the one that has your username inside of it right here. If you clone the other one, whoops, I need to copy the entire URL. Do that, and you hit enter, and it gives you some messages. And now if I type ls, I have a folder that's the name of the repository. If you put in the wrong URL right here, and you put in the Mike is Vicky URL instead of your URL, at this point, everything will work correctly. And this is sort of one of the really confusing things about the git command, is that very often when you run into error messages, the error is not at the location that you're actually typing in the command at. So you'll, if you do this git clone with the wrong URL, everything will still work correctly, but then in a couple other steps later is when things will break. So that's one of the confusing things about GitHub and Git. So let's go back to the cheat sheet. So we've done this step one, forking onto the other GitHub location, and then cloning from GitHub onto the Lambda server. Now we have to modify the contents of the repository locally on the Lambda server. And to do that, we'll use the Vim text editor. So I'll come back over here, and so type ls, here is my repository. I'm going to cd into that. And one of the things that's really nice about the terminal is that it's built for lazy people. And I am a lazy person, and so I hate typing. My fingers get cramps, and it's just awful typing when you type too much. And also I'm human, and I make mistakes. I think I'm typing something and I type something else, make typos all the time. So whenever I'm typing in a file name, I never actually type in the name of the file. Instead, I just type in the first few letters of that file, and then I hit the tab button. So I'm pressing tab right now, and you can see that it might have looked like I just typed really quickly and typed in the rest of the file name, but it actually completed all of that for me. So this is a habit that you'll want to get into, and I'll be emphasizing this throughout the course, is that you'll be using these shortcut keys like tab completion to reduce the chance of you making errors of typos, but also to make yourself a little bit more productive and faster at typing. So just, again, type in the first few letters of a file name, press tab, and it completes the whole file name for you. Now I hit enter, and I'm inside of this, this folder now. Type ls, and you can see that the contents here of things are now all of the contents that were on the web page. So going back to the web page, come over here to the repository, we have this extra credit folder, this week 0 folder, and then a bunch of files. And now if I go back over here, I see there's this week 0 folder. I know it's a folder because it's in blue. I see this EC folder. Again, I know it's a folder because it's in blue. And then these other files. You'll notice again that on the web page, there's this git ignore and git modules file, but those start with periods. So they're the hidden files on the on Linux file systems. And so typing ls does not display hidden files. If you want to display all of the files, it's ls-a for all. And now it shows this .gitignore and this .git modules file. It also shows one additional file that we haven't seen before called this .git file. And this is something that is internal to Git and something that you should basically always just ignore and never look inside of. Anytime you run these commands like Git Clone or any of the commands on the Git cheat sheet, which we'll be talking about here in a minute, what those commands are doing is they're internally modifying this folder and the contents of this folder. And so you should just let Git do its thing on that folder and never look inside of it. Let's see, we've talked about a lot of things so far. Are there any questions about anything that we've seen? I'm sorry, the chat Zoom has taken that away from me, so I can't see that right now. So if you do end up having questions, just interrupt me.
I have a question, Mike.
Go ahead. Yeah.
Is this all stuff that you were supposed to be doing alongside you right now, or is this just a demonstration?
Yeah, great question. So all of the stuff that I'm doing in class is the way to participate effectively in lecture is to have your cheat sheets handy and take notes on the cheat sheets, but you don't need to follow along in class. I'm going way too fast for people to be able to follow along like this. But on the lab on Thursday, there's instructions that'll have you sort of repeating these same steps. So that's when you'll get like the sort of the in-depth familiarity with like all of these things is during the lab time. Right now, the things to take away are just like the big picture ideas of how do all of these concepts kind of fit together.
Hey, Mike, I had a question as well.
Go ahead.
So when you fork the repository from GitHub, I'm assuming that any further changes on that original repository are no longer reflected on your clone, duplicate, whatever. It only takes it from that point, and that whatever your changes make are independent from any future changes in the original one. Yeah,
that's a great great question. So I'm gonna switch back here to this sort of cheat sheet that I have right here is just kind of like one way to use Git, one way to get things done with Git. But there's a lot more, and we'll see more kind of cheat sheets similar to this. And so the particular question was, what happens after I do this fork and now there's modifications up to this upstream? And the answer is those modifications will not automatically get sent down to your origin repository. You'll have to run some commands, which we'll talk about next week on how to do that. Great question.
Mike, when you do the tab command in the terminal, what happens if there's another file which starts with CMC, but is not the exact same, like CMC CSCI 045?
Excellent question. So right now I'm also teaching a class CMC-CSCI 143. And so now now there's two folders here that have the same start. And so if I was just do CD and then C and press the tab button, it won't know necessarily which of these two folders it should use. So I'll press tab right now and we'll see what happens. What it does is it completes it as far as it can until the two files have different things after them. So here the letters CMC-CSCI, it's the same in both of these folders, but then the number is different. So it does that for me automatically, but then I have to type a 0 so that it knows to go on to this one, and I press tab again, and then it completes it. Great question. Any other questions so far?
Hey, Mike, real quick. How do you paste into the Lambda?
Oh, this is a great question. So the question's about pasting into the Lambda server. This is one of the, I think it's the only thing that's going to be different for everybody depending on which sort of computer you're on. And so this will be getting the ability to paste, something better to handle during the lab session. The reason for this is that this is something that's handled, pasting is something that's handled locally by your own operating system. And basically when you do your own operating system's paste command, it will manually type in whatever is pasted and send that over to the Lambda server. And then once it's over there, it'll be the same for everybody. But actually doing the pasting will be different. So you might have to manually type in the URL at this point. Great question so far. Any other questions?
Yeah. Hey, Mike. So what's the difference between a repository versus a directory versus a folder?
Great question. So directory and folder are synonyms. They mean the exact same thing. So anytime I'm doing CD or PWD, these are all folders or directories. Directory is a slightly older name. It's the original name that was for when Unix was created in 1970. That's the name that they used. But then more recently, people started calling them folders, and now people just go back and forth and use them interchangeably. A repository is something that is, it's sort of a collection of files that are all together. If we go on to GitHub up here and say, I'm at this URL right here, this entire thing is a repository. So the repository contains these two folders inside of it, and it contains all of these files as well. It can get a little bit confusing because sometimes repositories and directories can sort of be the same thing. So right now I'm in this proj folder. This folder right here, CMC-CSCI046, is a folder, but it's also a repository, because if I go inside of it, then it has all of the information inside of it, and it's linked up to that GitHub repository via Git. Another word that you'll hear me saying sometimes is repo, and repo is just short for repository. And so I would say that I'm currently inside of the CMC CSCI046 folder. I'm also currently inside of the CMC CSCI046 repository. And at this point, both of those two things mean the same thing. But if I were to say, go back to my home folder and make a new folder called test and go inside of test, now I would say that I'm inside of the test folder, but this is not linked in any way with Git. And so I'm not inside of a test repository. I'm only inside of a test folder. Great question. Any other questions so far?
I have a question. How do you move a file from one directory to another?
Great question. So in order to move things, the command is mv, mv standing for move. A lot of these commands you'll find are basically just like whatever the verb is that you want to do minus all of the vowels. But mv will move from one location to another. Let's see, if one of the things that is sort of like moving, but maybe not obviously like moving, is renaming a file. So if I have this readme.md file and I want to rename it from readme.md, and I'll make my window here a little bit bigger for a second, from readme.md to example, you do mv, then the original location, and then the destination location. Hit enter, type ls, and now it's no longer called readme, it's called example. And now I'll move it back from example to readme, and now it's called readme again. One of the things that you'll notice is that at this point, all of this stuff left to the $sign is called the command prompt on a Linux terminal. And my command prompt has a lot of things inside of it right now. We'll talk about the details of what all this means later. And as part of the lab, when you first log into the Lambda server, your command prompt will look different than mine. But part of the lab is asking you to go through the instructions of running the right commands in order to make your command prompt look the same as mine. Let's see, any other questions? They've all been great questions so far. Okay, we'll go, let's review, go back to our cheat sheet for a second so we can sort of see what we've done so far. We had our repository, it was upstream in the cloud. We forked it into our own repository, so it's no longer the maintainers, it is our repository. And then we cloned it from GitHub onto the Lambda server. Now we need to edit the files locally on the Lambda server. And the way we'll do that is with Vim. That is our text editor, Swiss Army knife of choice. And so the file that I want to edit was over here under week 0. The problem was that Unix was in all capitalized and I wanted it to be all lowercase. And so I need to move into this week 0 folder and cd week 0, and now ls, and it's this readme.md file right here. In order to open up this readme file, I type vim and then the name of the file that I want to open. So in this case, I'll type a capital R and then press tab, and it will open this file for me. And so I'll hit enter. And now here's all of the contents of this file. This file is in what's called a markdown format. The MD stands for markdown. And this is like a really simplified version of a really simplified annotation system for making sections and bullet points and things like that. And then when we upload it to GitHub, it converts it into something pretty that gets displayed to the user. So here on the very first line, we can see is where the that typo is, where it says Unix. And so what I'm going to do is move my cursor over to the Unix and replace it with a lowercase version. There's a lot of ways that you can do this in Vim. So the most straightforward is pressing the L key to move your cursor over to the right like this. But again, that's, I don't know, that's like 12 keystrokes and my fingers are tired. It's been a long day. I don't like typing all that. So I'm going to use a special Vim command in order to do it. The command that I'm going to use is the F key, F standing for find. And then whatever I type next, the cursor will move to the next location of that letter. So I'm going to type a capital U. So F capital U, and my cursor just moved instantly to that location. And I didn't have to worry about moving manually over that many spaces, and maybe I moved too many or too few. These sorts of commands are things that at first seem like very obtuse, and why would, like, okay, it's only 10 keystrokes, it's not that big of a deal. But after you get like comfortable with these commands and they become muscle memory, then you can just edit documents super, super fast. Okay, the next thing I'm going to do is I'm going to enter replace mode. So I'm pressing capital R, Shift R, and you can see I'm in replace mode now because in the bottom left it says replace. And I'm going to just retype over this in lowercase instead of uppercase. Press escape to go back to insert mode, or sorry, back to normal mode, and now we're good. It turns out, though, that that's actually not the only location in this file where I made that mistake of capitalizing Unix. And so I want to search this file for other locations. In all Unix tools, whether it's Vim or we'll see more examples later, if you need to do a search, then the key to press is always the / key. In Windows, / comes up a lot. So a lot of Windows users are very used to saying / and typing /. In Unix, we basically never use the / and it's always /. So on my keyboard, the / is right next to shift. I press it, and you can see down in the bottom left, I get the / right here. And I'm going to type in Unix, so it jumps to the other locations where Unix is located. Hit enter to go back into normal mode, and you can see that this is all highlighted for us, so we know exactly where the locations are. And I'll just repeat that same command that I did before of Shift R and then Unix by itself and escape. I'll press now in order to go to the next search result that I find, I'm going to press the N button, standing for next, and it automatically takes me to that next search result. And now, you know what, I'm kind of sick of typing things. Typing in Unix, that's 4 characters, way too much for me. My fingers are tired. And so I'm going to press the period button on my keyboard. And the period repeats whatever command it was that you previously typed. So the previous command that I typed was Shift R, then Unix to make everything lowercase, and now just pressing period made it, repeated all of that for me and made it lowercase here. I'll press N again to see if there's anything else, and pattern not found. So we've made all of the replacements. And I'll save this :WQ, W standing for write, Q standing for quit, and hit enter. And now we've made those changes locally on this Lambda server. Again, all of those sort of like Vim commands that I used, totally okay if, yeah, you should not, I'm not expecting you to memorize those. I'm not expecting those to be in your muscle memory yet at this point. But this is starting to give you a sense of some of the power of Vim and why we want to start using these commands. We're just scratching the surface at this point, and we'll see that all of these sorts of commands in Vim really, really will pay off in the long run. So I realize it's a difficult, very different system to get used to. A lot of, let's say, I'd say like the standard kind of thing that people say is it takes you about 20 hours of working with Vim before you become productive with it. So if you're working on this class in Vim 5 hours a week, then expect about a month from now is when it would be sort of standard and everything is comfortable again. Okay, so that's using Vim to edit the file. And let's go back to our cheat sheet, and we'll see that there are 2 more commands that we have to do in order to actually modify the file on the server. Right now, we've modified the file, but we haven't told Git about the modification to the file. And this Git Add and Git Commit commands are the important parts to telling Git that we've made the change to the file and we want to save it. If you look at your, well, let's see, before we talk about Git Add and Git Commit, there's one real quick command for Git that I want to show us, and that's Git Status. And Git Status tells us what all of the different things that we have changed about this file are. You'll see in red right here is the readme.md file, and it says these are changes not staged for commit. That means we've made the change to the file, but Git doesn't know about this yet. And so the next command is Git Add, and then the name of the file that you're adding. So in the notes right over here, file is always the name of the file that you're adding. So Vim file, I've edited it. Now Git Add that file name. I'll hit enter. And now if I were to run Git Status again, which I'll do by pressing the up arrow on the keyboard, the up arrow lets you go to previous commands that you have typed in so that you don't have to retype them. So I'll press the up arrow twice, since it was 2 times ago that I ran Git Status. And now we see that this line right here is in green, saying that, well, the technical name for this is that this readme.md file is in the staging area. This red is unknown to Git. This green is the staging area for Git. And this is like a kind of temporary workspace. For our purposes in this class, we're not really going to care about the staging area, but it ends up being really important at scale when you're at Facebook working with millions of files. And so For us, it'll be immediately after you do git add, you do this git commit command. And git commit says, take whatever's in the staging area and make it permanent. As soon as you run the git commit command, it's going to open up a Vim window. And in this Vim window, you enter what's called a commit message. And this is a short one-line thing about what change you made. And I'll say that I fix typos. There's a lot of different standards that companies use about what should be in commit messages, but generally the most common thing is that it should be like a command form, like you're ordering the computer to do this. I'm ordering you, computer, to fix typos. So second person for all of the verbs should be in the second person. In this class, we're not going to grade about the commit messages. It doesn't really matter what you type. But that's just, you'll see a lot of people saying things like that if you find tutorials online. After you run git commit, you'll see a summary of all the different changes that you made. So how many files was it that you modified and how many lines were updated. In this case, we didn't really delete and insert lines. Instead, we modified a line, but you can think of a modification as just a deletion followed by an insertion. So that's why it says 3 deletions and 3 insertions instead of 3 modifications. If I were to run Git Status now, you'd see that there's nothing, no red, no green. That means that all the changes that I've made, Git knows about, and it's ready to work. So back to the cheat sheet, we've done this process right here, modification on the Lambda server. Our next step is to get the Lambda server up into the origin, and the command for that is git push. This origin right here is the location that you're pushing to. So we're pushing to our origin project. In this class, it'll pretty much always be git push origin. And then this last bit over here is what's called the branch on Git that we're trying to push to. And so I want to say a little bit more about what this branch means. If we'll go back to the repository over here, and this button right here is what controls the branch that we're looking at. And if I click it, you can see that there's 3 options right now. There's 2021 spring, but then there would also be 2020 spring. So when I taught this course last semester, and so if we clicked on that, and whoops, I think I'm on the example student instead of the original one. So here we are, now we're on the original one. Now we can go back to the 2020 spring branch, and you can see here's all of the course materials from last year. So if you're itching for a sneak peek of things to come, you could see it this way. But this is a way for me to keep track of everything that I do for all the classes I teach and still use the same repository for different versions of the class. So this, when you see on the cheat sheet right here, whatever is the very last part right here in git push origin master, this last part up here needs to match whatever this part right here is. This is the name of the branch. And so because it's 2021 spring is what we're working with, the command will not be git push origin master, it'll be git push origin 2021 spring. So I'll come over here and do git push origin 2021 spring and hit enter. And it'll ask me for my user credentials. And this was example student. And type in my password. So again, just like when you're first logging into the Lambda server, when you type in passwords for Git, it's not going to display anything, but it is recognizing that, and it outputs all of this stuff, which indicates that it was successful. And now if we come back over to our web page and we want to look at the forked version or the origin version. So I'll start by looking at the non-origin version, and we'll see that it's still capitalized right here. Right now I'm in the Mike is Bicky version, the upstream version. We're looking at this one up here. And so we haven't changed anything in this one up here yet. We've only changed in the origin, because we did git push origin. We've only changed this one. So in order to see the change, we have to go to the appropriate URL, which is example student instead of Mike Isbicki. And let's see, did I have a typo? There we go. /cmc-csci046. There we go. So this is my forked repository. We get this message right here saying that we've made a commit. Come down to week 0, and we see now that everything is lowercase instead of uppercase. So the change only happened in this one and not in this one when we did git push origin master. In order to make the change go from here to here, we have to, so we can't force that to happen. We can only request that it happen with this pull request. And if I, there's this button right here, it says pull request. You click that, and it gives you a little summary of all the changes you made. So this is called a diff of a file, it stands for difference, and you can see what all the changes were that were made. And so this makes it really easy for me when you submit a pull request. I can just look at it and see, oh, what change was made was just fixing this typo right here. It's a great change. I want to accept the pull request. So from your end, though, one of the common mistakes is that just because you press the pull request button once does not mean you've actually created a pull request yet. This is just sort of a summary of what would happen if you created a pull request. So you have to press this green button again, and then this green button again. So it ends up being 3 buttons that you have to press to actually create the pull request. Once you do that, you'll see this tab up here has a number of pull requests inside of it, and then I can go through and choose to accept or reject those pull requests. So I'm going to switch to my window that has me logged in as me instead of example student. So I'm now logged in as me. I'll refresh this page. We got this pull request over here. This is the one that I just created by example student. Click on it. And if I want to look at the diff, I can press this button right here, and it shows me all of the differences that were made. I like these changes, so I'll press back and press merge pull request, confirm merge, and this has said now all of those changes are actually added into this final upstream repository. So that is the full cycle of this pull request step. First the fork, then git clone, making sure that you're cloning the origin URL and not the upstream URL. You do all of those commands on the Lambda server. That only affects the Lambda server. Git push origin, the name of your branch, in this case 2021 Spring, and then finally the pull request back up here. It's a very complicated process. So if you're feeling a bit overwhelmed right now, that is perfectly okay place to be. Actually going through the steps in the lab tomorrow will help cement this process a lot more for you. But even after that, it's still gonna feel like a little bit overwhelming and confusing, and like, why are there so many steps involved in this? Yeah, the answer to that is that it is actually as simple as it can possibly be. There's just, when you're working with big companies like Facebook, there's a lot of things that can happen, and you have to handle all these cases. And so we just need to, at this point, have all of these steps memorized and accept that that's just the way it is.
Mike?
Yeah.
What happens if I tried to just clone the upstream repository and then do a push origin master?
Great question. So the question is, if you clone the upstream and do git push origin master, it's going to ask you to type in your credentials when you do git push origin master, and you'll type in your username and password, and it'll say access denied because you don't have permissions to push to this. Wherever you do git clone from, that is what Git thinks is the origin. So even though right now I have this labeled as origin, the reason this is called origin is because I did git clone with this URL. If you did git clone with this URL up here, then when you did git push origin master, it would try to push directly to this, and you don't have permissions for that. Yeah, so short answer is you'll get an error message, permission denied. Any other questions?
Yeah, Mike, I have a question.
Mm-hmm.
So what if I forked your repository, and while I was working on it, you made some changes to your original one?
Yeah, that's a great question. We'll talk about that situation next week. There'll be a few more steps that you have to do to then update your repository to get the latest version of mine. This is, yeah, so over, let's see, yeah, next week we'll see a few more variations of this theme. By the end of the course, we'll have about 5, 6, or 7 different variations of all of the different things that can go wrong and how you fix them. But for now, this is the one that you'll need for the lab and homework. Let's see, if anybody does have more questions, we have about 10 minutes left in class, so I just want to make sure that I talk a little bit about the homework first. But we do have office hours afterwards, so I'll be able to stick around and answer in detail any questions that people have after that. And so for your, here we go, for your lab and homeworks, they're always going to sort of follow the same format in terms of where they're located. You'll always have whatever week we're on, and then in this file down here, you'll scroll down and get your lab information. And the lab, these steps right here are essentially just asking you to work through the same sort of procedure that we did with a few kind of mild twists in there. It's very likely that as you're going through them, things might not work 100% perfectly for you on the first try. So that's why I definitely recommend coming to lab on Thursday. So I'll be available to help you iron out those kinks. But again, the lab is not required for you to attend. If you're confident that you can do it on your own, then feel free to do so. For the homeworks, the homework will always be posted as a link up here. And if you click this, it'll take you to another project. And this one is called Continuous Integration. And we're going to be, or what this homework is trying to do is to get you familiar with how the grading system is going to be working in this class. That for all of your homeworks, you're going to basically be forking a GitHub project, and then you'll have your GitHub project hosted online, and you'll push your code results onto that GitHub project, and there will be a set of test cases that run for your project. And if your code is successful, if it completes all of the test cases without any errors, then this image right here, instead of being red, will show up as green, and that's how I'll know that you did it perfect on your homework and give you full credit. If it shows up as red still, then what I will do is I'll click up here under Actions, and I'll go in and find in detail exactly what were the test cases that failed. For this homework assignment, there's very, very little coding that's actually required for you to do. There's this fixme.py file, and it has 2 functions inside of it, a function called factorial and a function called triangular. And the triangular function is not currently implemented, but the factorial function up here, factorial function is currently implemented. In order to implement triangular, all you have to do is take this code and replace the multiplication with addition, and you'll have a fully correct Python code. The way, let's see, if you didn't take CS40 with me, you might not be super familiar with this string that happens after each function. This is called a doc string, and it contains all of the tests that your code has to pass. And so here with this factorial function, if you were to open up Python and run factorial 1, you would get the number 1, factorial 2, the number 2, and so on. And the code, the way that it knows that it works is it runs all these and just checks to see that it gets these as the outputs. And so these you could probably do by hand. This one would be obnoxious to do by hand, and this one would be super obnoxious to do by hand. But the code will do it for you. And so down here, it'll have these test cases as well. Do it all by hand, or sorry, here's the function that gets called with this input, and it'll get this output. And if your code does get this output, then you'll pass the test case.
Quick question.
Yes, go ahead.
So like the test cases being in the doc string, does that automatically tell Git in the actions to run those test cases, or is that specified elsewhere?
Yeah, great question. So what I'm going to do right now is I'm going to go ahead and clone this project onto the Lambda server. So I'm going to go back to my home folder. Anytime you do cd by itself, it will take you to the home folder. And now I will we'll go into projects, and we'll do git clone, then that URL right there, cd into the folder. Here's all the files, and this fixme.py is what we have to modify. So vim fixme.py, and I'm going to come down here and put in some correct code. Again, just changing that star to a plus makes it correct. :WQ to save and quit. And now, in order to run these test cases from the Lambda server, the way you would do that is Python 3-m doctest, and then the name of the file. Hit enter. If you get no output like this, it means that all of the test cases passed. So I'm going to come down here and delete this line, save and quit that, rerun the doc test like this, and we see we get a bunch of tests that do not pass. When you one second, when you upload this to GitHub, it's automatically going to run this command for you. So you're not necessarily required to do it on the Lambda server, but you could in order to save the step of uploading it to GitHub every time. And then if that button turns green, it means that there was no output and everything passed. Sorry, go ahead.
So does doctest automatically, like if we didn't specify any test cases in the doc string, would it wouldn't run any test cases?
Correct. Yeah.
Okay.
So in this class, you'll never have to create your own test cases. Instead, I will provide you test cases for all the things that I'm asking you to implement. Great questions. Any other questions about the homework or the mechanics of the homework? What to expect from it? Okay. Yeah, so again, probably you will encounter questions at some point when trying to do all that Git process. It is, even very experienced programmers can get very confused with Git sometimes. So don't feel like you are somehow behind or anything like that if you're feeling confused by Git. And again, so yeah, Thursday, tomorrow, we'll have a chance for you to review and practice all of these things in lab. And normally the labs and homeworks would be due on Sunday night, but because this is the first one and there's all of these sort of very new complex things, there's no late penalties if you can't get it done by then. And you'll have the chance to ask questions and make sure that you're able to get everything ironed out and get full credit on this first assignment. Yeah, so with that, let's see if with the weird state Zoom is in, if I can get it to stop sharing screens. Let's see, I think, so Zoom is hiding the not sharing screen button from me. So what I'm going to be doing is I'm going to log out. That will be the official end of course. And then I will log back in and that will be the official start of office hours. And so if you do have questions, which again, totally understandable, I would too, now would be a great time to ask them. Or again, Thursday during the lab time, you can do that. But also, yep, if you choose not to come to either of those, then I will see you next week.
Thank you.
Thank you, Mike.
Thank you.
I have a quick question.
Sorry, let me gonna log out and come back in
Okay.
so that the Zoom resets.
Okay.
And actually, it looks like I can't do this right now without logging everybody out. So if you have questions, then